Everyone, for today's lesson we are going to learn about geometric sequences and how to write explicit rules for geometric sequences. Before we get started, I wanted to let you know that we are going to do our warm-up together in class the next time I see you. So no warm-up for our video lesson. We're just going to hop right into our actual lesson for today. Our learning objectives is for you to be able to say, I can tell whether a sequence is considered arithmetic or geometric, and I can write an explicit and a recursive rule for a sequence given either the first few values of the sequence or given any two terms of that sequence. So let's talk about what a geometric sequence is. We learned in the last lesson that an arithmetic sequence is related to linear functions. And that's because we are adding the same number each time in order for us to get to the next value. And that's something that we would see in a linear function. For geometric sequences, we're multiplying by the same number each time in order to get to the next value. And whenever we've had a constant multiplier, that has always indicated that we've been working with an exponential model. So geometric sequences, in a geometric sequence, the ratio of any term to the previous term is constant. That means that we're going to be multiplying by the same number each time in order for us to get to the next value. This constant ratio is called a common ratio, and it is denoted by the letter R. So whenever you see the letter R, that's the number that you multiply by each time in order to get to the next value. Now, R is found by taking your term and dividing it by your previous term. So taking the term that you are currently on and dividing it by the term that came before it. So your R value is going to be equal to A sub n divided by A sub n minus 1. And A sub n represents the term that you are on, divided by A sub n minus 1, which is the term that came before. So we're going to be working with this formula as well as a variation of this formula later on in our lesson. So let's go ahead and look at our first example to tell whether or not a sequence is considered geometric. So it says analyze whether the sequence is geometric, and in words explain your rationale. So let's go ahead and look at our situation. We're going from 1 to -4, -4 to 16, 16 to -64, and -64 to 256. Now there are a couple of ways that you can show your work and show your thinking. The first way is to say, okay, I can tell that to go from 1 to -4, I would need to multiply by -4. And I can multiply -4 times -4, and I would end up with positive 16. And 16 times -4 is equal to -64, and -64 times -4 equals positive 256. Therefore, because we're multiplying by the same number each time, in which R is equal to -4, this is considered a geometric sequence. Another approach is for you to divide. Sometimes the numbers that are going to be given to you are going to be pretty large numbers. So you might be in your best interest to identify your the ratios between your terms. That means that you would take -4 and divide it by 1 to get -4. And then you would take 16 and divide it by -4 and show that that also equals -4. Then -64 divided by 16, and that equals -4. And finally, 256 divided by -64, that is also equal to -4. So this is another approach, and you would need to show it that each ratio is equal to -4, because we know that sometimes in a sequence, all it takes is just the last couple of numbers in that sequence to not work for the whole sequence to not be whatever it is that you were analyzing. But in this case, R is indeed equal to 4, and this example is indeed geometric. So we would say, yes, this sequence is geometric because the common ratio is -4 between each term. All right, let's go ahead and look at letter B. For letter B, we have 512, 128, 64, and 8. And we want to determine if the sequence is geometric, and we want to verify our answer. So because these numbers are a lot larger than numbers that we necessarily work with, I would recommend strongly that you work with a calculator. So I know that R is equal to your term divided by the term that came before. So I'm going to see what 128 divided by 512 is. And if I were to go 128 divided by 512, 128 divided by 512, I end up with a decimal, 0.25. I know that that's a 1/4. So this is equal to 1/4. So now I'm going to divide 64 divided by 128. So my next term divided by my previous. So I'm going to go 64 divided by 128. And I end up with 0.5. Okay, that's 1/2. These two numbers are not the same. So therefore, this is not a geometric series or sequence, or the sequence is not geometric. So no, the sequence is not geometric. Because the common ratio is not the same between each term. All right, so just like I just said to you a little bit ago, geometric sequences will follow under the model of an exponential function. So the explicit rule or the explicit formula for a geometric sequence is going to be very similar to an exponential formula or an exponential function. The formula that we're going to be working with is a sub n is equal to a sub 1 times r to the n minus 1 power. That's in order to get to your next term, or any term is going to be equal to the first term times your common ratio raised to the n minus 1 power. This is similar to y is equal to a times b to the x power, which is the general form, or the most the simplest form of any exponential function that we've given. Now, if you remember, when I gave you problems like this, the a value represented your y-intercept, or your starting point. And that's related to a sub 1. A sub 1 is your starting point. Your b value represented your multiplier. How quickly that function was increasing or decreasing. And then it was raised, of course, to the x power. And it follows the same exact model. R is going to be the number that we're multiplying by each time in order to get to our next value. And a sub 1 is where we start in terms of our sequence. So this time around, our ordered pairs, just like we had before, are still going to be n comma a sub n. And n, once again, represents your term position. And a sub n represents the number in that position. So that is still going to be consistent between our last lesson and this lesson. So for example number 2, we want to write a rule for the nth term. And whenever you see that language, write a rule for the nth term, I'm asking you to write an explicit rule. So our explicit rule, once again, is going to be written in the form of a sub n is equal to a sub 1 times r to the n minus 1 power. So that whole thing is going to be raised to the n minus 1 power. And you want to make sure that it doesn't look like this minus 1 is down in the same line with the other terms. So just be careful whenever you write your numbers. Then we're going to let n equal 10 because we want to find a sub 10. So we're going to let n equal 10, and then we're going to find the number that's in the 10th position of the sequence. Then we're going to write a recursive rule. And remember that recursive rules require you to know what came first. So we're going to write our a sub 1, and that's going to represent our first term. And sometimes you know it and sometimes you don't. So we have our first term, and then we're going to write a sub n is equal to your common ratio, which is r, times a sub 1 minus 1, which represents your previous term. So let's go ahead and look at letter A. For letter A, I have 972, negative 324, 108, and negative 36. These are a little bit larger of numbers. So what I would recommend that you do is pick two and use your calculator to come up with your common ratio. So I'm going to work with negative 324 and negative 972, and I know that my r value is equal to the number that's in the higher position divided by the number that came before it. So that's going to be negative 324 divided by 972. So in my calculator, I'm going to be using that math enter trick. Unfortunately, you guys are allowed to use a graphing calculator on your test. So I'm going to go negative 324 divided by 972. I end up with negative 0.3 repeating. And I'm going to go math enter, and I end up with negative 1/3. So my r value is going to be equal to negative 1/3. So now that I know what my r value is, I need to identify what my first term is in order for me to write my rule. So I have my first term is 972. This is my a sub 1. I have my r value. So I'm ready to write my equation. It's a sub n is equal to a sub 1, which is 972, times, and I would recommend strongly that you put your r values into parentheses. So that's going to be negative 1/3 raised to the n minus 1 power. The reason why I would recommend you put it into parentheses is because whenever you are entering things into your calculator, it becomes a little bit better and more accurate if you were to put those values into parentheses. So that's number one. The next thing that we needed to do is we needed to find what the 10th term of this sequence is. So that means that I'm going to let n equal 10, and I'm going to identify the number that is produced. So letting n equal 10, I'm going to write a sub 10 is equal to 972 times negative 1/3 raised to the 10 minus 1 power. And you can use your calculator to enter this whole thing into your calculator exactly as you see it, because there are no variables. We can simply solve it or enter it into our calculator with ease. So I have 972 times negative 1/3, and I'm going to raise this to the 10 minus 1 power, which is the 9th power. And that is equal to negative 0.049, and this is a decimal. Now, I recommend strongly that you use a graphing calculator on your test and you go math enter, because I'm going to be requiring you guys to give me your answers as fractions unless otherwise specified. So in this case, our 10th term is negative 4/81. So I'm just going to put negative 4/81 into my ordered pair. And finally, step number 3, I'm asking you to write a recursive rule. So a recursive rule means that we identify our first term, which is 972, and then we write a sub n is equal to our r value, which our r value was negative 1/3, times our term that came before, which is a sub n minus 1, and that is our answer. All right, let's go ahead and look at letter B. For letter B, we have 14 to 28 to 56 to 112. This one's a little bit easier. To go from 14 to 28, we're going to be multiplying by 2. To go from 28 to 56, we multiply by 2. To go from 56 to 112, we multiply by 2. So my r value in this case is 2. My first term, a sub 1, is equal to 14. So if I were to write my explicit rule, that's going to be a sub n is equal to 14 times 2 to the n minus 1 power. Step number 2 is I need to identify what term comes in the 10th position. So that means I'm going to let n equal 10 into my explicit rule. What's really nice about explicit rules is that you do not need to know what came before in order to find the next value. I don't need to know what came in the 9th position in order for me to find the number in the 10th position. So that's one of the really nice things about explicit rules. But anyways, I'm continuing on. I'm going to let n equal 10, and I have a sub 10 is equal to 14 times 2 to the 10 minus 1 power. And I'm going to put that into my calculator exactly as I see it. and I end up with a sub 10 is equal to 7,168. And there's my answer. And finally, step number 3 is we need to write a recursive rule. A recursive rule requires us to identify our first term, which our first term is 14, and then requires us to know our multiplier. And so since our multiplier is 2, I'm just simply going to write a sub n is equal to 2 times our previous term, a sub n minus 1. And that is our answer. There's nothing further for us to do for example number 2. So let's go ahead and write a rule for a geometric sequence given 2 terms. So just like we did in our last lesson, where I gave you 2 terms and we picked one of the points and plugged it in after we found our slope, and then we were able to come up with our equation. Very similar format, very similar process for these types of problems. So if I'm giving you 2 terms of a geometric sequence, in this case I'm giving you a sub 2 equals 10 and a sub 7 is equal to negative 320, I recommend strongly that the first thing that you do is write those as ordered pairs. This is 2, 10, and 7, negative 320. This lets you know that we're just working with ordered pairs. Then we want to write a rule for the nth term, which once again means that we're writing it as an explicit rule of a sub n is equal to a sub 1 times r to the n minus 1 power. So in order for us to write this rule, we need to know 2 pieces of information. We need to know what came first, what's in our first term, the first term of our sequence, and we also need to know what our multiplier is. There does exist an order in which you want to find these values. And the number that you want to identify first is your R value. So that's going to be your first step. Find your R value. Then the second thing we want to do is we want to find our first term, where we're going to use a point of our choice and R to come up with our first term. We're going to plug that point and R into our function and solve for a sub 1. Then step number 3 is we're going to finally write our rule is a sub n is equal to a sub 1 times r to the n minus 1 power. All right, now finding r is a little bit trickier. There does exist a shortcut, but in order for the shortcut to make sense, sometimes you just need to see the visual. So I'm going to show you both ways. So to find r, let's talk about what our ordered pairs represents. What's happening here is that we have a number that's in the first position, and in the second position we have the number 10. Then in the third position, the fourth position, the fifth position, and the sixth position, we just have some kind of number. I'm not sure what those numbers are. We don't really need to figure them out. But I do know that in the 7th position, so this is the 1, 2, 3, 4, 5, 6, 7th position, we finally reach negative 320. Now we know that because this is considered a geometric sequence, that we're multiplying by some r each time in order for us to get to the next value. So I'm going to start with the number that came before our other, and that number is the number 10. And I know that in order for me to get to the next number, I'm going to be multiplying by r. And in order for me to get to the next number after that, I multiply by r. And I'm going to be multiplying by r each time until I finally reach negative 320. So let's think about it. R is supposed to be equal to some number divided by 10. This number divided by 10. This number divided by this number. This number divided by this number. But we don't know what that is. But what I do know is that if I were to multiply r times itself 5 times, I will finally reach negative 320. So this is r to the 5th power. R times itself 5 times will finally reach 320 if I'm looking at the distance between 10 and negative 320. Now because r is called a common ratio, that means that we need to write r to the 5th power is equal to a ratio. So just like r is equal to your next term divided by your previous term, r to the 5th term is going to be equal to the term that's 5 positions ahead divided by 5 positions behind. So in this case, it's going to be equal to the ratio of negative 320 divided by 10. So once again, because I have to multiply r times itself 5 times between 10 and negative 320, and r represents a common ratio, that means that I need to set r to the 5th power equal to a ratio of the number that's in the higher position divided by the number that's in the lower position. So now I'm going to clean up this problem, and I'm going to end up with r to the 5th power is equal to negative 32. And we know that in order for us to solve this, we would need to take the 5th root of both sides. So if I were to take the 5th root, the 5th power would cancel out, leaving me with r is equal to the 5th root of negative 32, which is negative 2. So there's my r value. R is equal to negative 2. Now, this is a long way for us to come up with r to the 5th. There exists a shortcut, and that shortcut is to look at your x values of your ordered pairs. The x values of your ordered pairs are 2 and 7. And I know that 2 and 7 are 5 units away from one another. So if I simply go 7 minus 2, that's going to equal 5. And this is going to represent r's exponent. That's another approach. So I can just go and take my x values, subtract them, and that's going to give me my exponent. So this work that I just showed you is just extra work, especially if you're a visual person, for things to make sense, for problems like these to make sense. However, if you're looking for shortcuts, your shortcut is to take your x values and subtract them. Big minus small, that's going to represent the exponent of r. And then you would take big minus small in terms of position. So even if negative 320 was smaller than whatever this number is, position-wise, it's larger. So I would take this number that's in the higher position and divide it by the number that's in the lower position and set it equal to r to a certain power. So now that I know what r is, the next thing I need to do is I need to identify what my first term is. Now, some of you might be able to say, well, can't you just use r and divide backwards and, come up with your answer? Yeah, you could do that. However, I'm giving you nice numbers right now. I could potentially give you the 20th term and the 70th term, and that could be a lot of extra work in order for you to come up with your first term. So I'm going to be requiring you to be able to identify your first term algebraically, and that's what I'm about to show you. So this is step number 1. We identified what our r value was. Let's go ahead and do step number 2. Step number 2 is where we want to find our first term. So I need to pick a point, and the point that of course sings to my heart is 210, because I think 7 negative 320 is a little big. And I'm going to work with my r value and plug those values into my formula. So my a sub n is going to be 10, and that's going to be equal to a sub 1, which is what I want to find, times my r value, which is negative 2, raised to the nth power, n, which is 2 minus 1. So now I need to solve this equation for a sub 1. And I'm going to clean up this side just a little bit. 2 minus 1 is 1, and negative 2 to the first power is negative 2. So I have 10 is equal to a sub 1 times negative 2. I'm going to divide both sides by negative 2. And when I do that, hold on, let me make sure that this looks clean for you guys. I'm going to divide both sides by negative 2. I end up with negative 5 is equal to a sub 1. So that means that my first term is a sub 1. I have my first term. I have my r value. Now I'm ready to write my equation, which is step 3. Step 3, I'm going to write my equation as a sub n is equal to my first term, which is negative 5, times my r value, which is negative 2, raised to the n minus 1 power. And that is it. That's my answer. And as well as the end of this lesson, I'm going to do letter B with you guys the next time I see you in class, along with the warm-up. So if you have any questions over anything, please feel free to email me or talk to me next time I see you in class. Otherwise, I hope you have a wonderful day.